as a check, we know that if you calculate volume of a rectangular prism, it's length times width times height. So length is 6 feet. The width is 2 feet. And the height is 1 foot. You multiply that together, you get a volume of 12 cubic feet. So this shows you that Simpson's rule can be used to approximate the displacement of your vessel. If you have a lot of curvature, you probably want to modify it so that you have more stations to calculate the area and displacement of your vessel. Okay, now you've seen how to use Simpson's rule to calculate the displacement of a simple shape like a barge. Now I've taken the barge and replaced it with a more pointed end, and I'm going to show you how you can use Simpson's rule to calculate the displacement of this vessel. So this time I'm going to start off with making a table, because when you get to the point where you're calculating the centers, using a table will be much easier. So the first thing I'm going to write down is each of my sections. Next, I'm going to write down the area for each of the sections. Now, from previously, we found the area at sections 2, 3, and 4 because it was just the beam times the depth of water to the water line. So that we found was 2 square feet. The area at section 0 is just 0. There's no area there, it's just the point of the bow. The next one we actually have to calculate is the area at section 1. Because it's considered to have a constant cross-section, if you look here, I've gone ahead and labeled the beam at this point, or the half beam, is 1/2 of a foot. So that means the total beam here is 1 foot. So if you were to look at your section view here, this area would have a dimension of 1 foot, and the draft is 1 foot. So that means the area of this piece is 1 square foot. The next thing we need is our Simpson's multiplier, which I'm going to abbreviate as SM. So our Simpson's multipliers, if you remember, follow the format of 1, 4, 2, 4, 1. If you were to have 7 sections instead of 5, your numbers would be 1, 4, 2, 4, 2, 4, 1. So you always increase the number of 4s and 2s in the middle, and you always end with 4, 1, and you start with 1, 4. Okay, so the next column is going to be multiplying our area times our Simpson's multiplier. For that, we get 0, 4, 4, 8, and 2. If we total that, we get 18. Now we can plug that in to our Simpson's rule formula and calculate the volume. If you remember, Simpson's rule, if we simplify it, is the volume is h over 3 times the summation of the area times the Simpson's multiplier. Our h spacing has remained the same. 6 feet divided by 4 is 1.5 feet. So 1.5 feet divided by 3 times the summation that we calculated here, 18. That is feet squared. Okay, when you do the math, you'll come up with a value of 9 cubic feet. That is our volume. Now it is necessary to calculate the displacement of the vessel. How much water in weight, pounds, is going to be displaced. The displacement is equal to the volumetric displacement times the specific weight of water. Since our boat will be tested in fresh water, we're going to use a value of 62.4 pounds per cubic foot for fresh water and our volume of 9 cubic feet. When you multiply those together, you get a value of 561.6 pounds. The units are pounds because the feet cubed cancel out between the numerator and the denominator. So that is how you calculate the displacement of your vessel using Simpson's rule in section areas.